So we've done a bunch of work on both circular motion as well as work and energy, and we've sort of had the topic separate. But we're going to look at a couple really common cases where the two things actually come together. So the first one is something like this, like a roller coaster or like a Hot Wheels track, and we're playing with, like Hot Wheels toys and stuff. That anytime you have like a vertical loop type situation, and you just look at it, it's round, so you might think circular motion. But the big thing is the speed at the bottom and the speed at the top are not the same. And so since the speed's not constant, a really great way to look at the difference in speeds and how much things speed up and slow down due to a change in height is by using energies. So of course at the bottom of the loop here, you'd have the car coming in, and it's all kinetic energy down here. And of course at the top of the loop we'd have potential energy as well as kinetic energy. And obviously the kinetic energy has gone down because it's moving slower, and that's because it changes into potential energy. So one of the big things would be to find out how much speed it actually has at the top after losing some of that energy to gravitational potential energy. And then once you have that, you can then take that and you can then apply it to forces. Because of course to go around a circular pathway like this, that definitely involves centripetal force. So the thing is, if you're going a vertical loop, especially Hot Wheels cars, which aren't actually attached to the loop, you need a certain speed to go around in a circle. And we've done this type of thing before, where you can actually check to see if you have the minimum speed required to go around. And of course, to find out how fast you're going, that would be the energies. So you might be able to see that you sort of got two topics, but what binds them together is the speed. We often use the energies to find out how fast you're going at the top or the bottom or anything like that. And then once we have that, we can then apply those speeds to FC to find how the forces actually connect together. Or vice versa, we happen to know the forces, and then we can use the forces to find the V, and then we can apply that to energies to find out how tall the loop is or how fast they're going to the bottom and stuff like that. So speed is typically the one thing that binds the two topics together. Use energies to find the speed, and then use that to find the forces, or vice versa, use the forces involved to find the speed, so then you can actually apply that to the energies. The same type of idea applies to situations when people or whoever are swinging on a rope or a chain or something like that. Whatever it is, swinging questions are another great example of when the two ideas get spliced together for the exact same reasons. As the person is swinging on a rope or whatever it is, they have a change in energy. Okay, so a change in energy, whether it's it's potential or kinetic, going back and forth. Typically, swinging on a rope, you start with potential energy and it changes to kinetic energy, and then at the bottom of the swing, you've got tension on the rope or whatever you're using. So once again, it's really, really common to use the energies to find the speeds, especially at the bottom of the swing. And then we can take those speeds that we have at the bottom of the swing and apply them to the centripetal force, which of course is then connected to the tension in the rope or whatever you're using. So once again, the speed binds the two things together. So a typical thing is to find the potential energy the person started with. Use that to find their kinetic energy at the bottom, to find out how fast they're going. Once you know how fast they're going, you can find their FC at the bottom, and then maybe add that FC to the force of gravity of the person, because those two combined together would give you the tension in the rope at the bottom. Okay, or vice versa, the tension of the rope at the bottom, use that to find your FC and your speed, and then work the other way and find out maybe how fast they were going when they were swinging, or how high up were they when they actually started. So these are two really common circumstances when energies and forces have to be used together, and it's mostly because the speed's changing. It's not a constant speed, and using energies, the change in potential, change in kinetic energies, is a great way to actually find those speeds and then apply them to forces. Now you have two other videos on the channel. I think they're video number 14 and 15, which are both examples of this type of thing. One uses a vertical loop. I think it's a Hot Wheels car with a vertical loop. The other one is somebody swinging. And again, using a combination of energies and forces and webbing them together to find out different quantities.